Okay, this video is basically on sketching the derivative, and I'm going to give you some calculator tips. But before we start all that, I want to kind of go through the steps that you do to sketch a derivative. And part of this goes with the notes we did last time, talking about if a function is increasing and if a function is decreasing, how that affects your derivative. So if you have your original function f of x and it has a maximum, I know that the derivative is equal to 0, or if you will, your slope is 0 at that turn. Okay? Because that is 0 on your derivative graph, it's an x-intercept. It's always a number 0, and this is on your f prime of x graph. When f of x is increasing, we talked about this before, we know that your first derivative is positive, or your slopes are positive. Okay? When we graph the derivative, we know that that means, because the slopes are all positive, the numbers are positive numbers, so it's going to be above the x-axis. When f of x is at a minimum, or not a turning point, but like a minimum point on your graph, I know the slope at that point is going to be 0, and that's another x-intercept, or a number 0 on our derivative graph. And then when f of x is decreasing, and my derivatives are negative, okay, that means that when we graph the derivative, it's going to be below the x-axis. Now I'm going to write some calculator tips, and I'm going to do some of these by hand first, and then I'll show you how to do it on the TI Nspire, okay? So here I have this screen here. First we're going to graph your original function. So every time you do this, I want you to graph the original function. And please do not use Scratchpad. Open a document and start a page, okay? Then you're going to hit Control G to graph another one, and you're going to graph the derivative. So you're going to hit Control G to actually put the derivative function in your F2 spot. Okay? Then when you do that, when that's open, I want you to hit the math template, and I'm going to show you what that is in a minute. And after you do the math template, you're going to find the derivative part of the math template. And it looks like this, d over d, and has a box there, okay? And it has a box here. So this is the derivative with respect to whatever. Usually it's x in our case, and then you're going to have a spot to put the function. So here, we're going to put here, I'll put an x in there, and here if you've graphed it in f1, so here's f1 of x, you've graphed your original function, we're going to put f1 of x in here. In that spot, so that your calculator will actually graph the derivative of that function. Okay? If you don't want to type in that, you can use the variable button, the VAR button on your calculator. That will place it, while you're highlighting this, will place that in your graph. Okay? So let's kind of practice some of these by hand, and then we're going to do that together, those calculator tips, a little bit later. Okay? So here's the first one. I have a line I have here, and we know that derivative means slope. So if I ask you to graph the derivative of a line, okay, we know this means slope. I look at this and I'm like, well, this slope here is constant because it's a line. The slope is constant. So in order to graph this, what would be nice is if we knew what the slope was, that'd be easy to graph the derivative, right? So I have a constant slope here. So I look at it and say, well, linear function, constant slope, how am I going to graph this? So linear function, let's write that down first. Okay, so what I'm going to do is actually stack and rack and find out what the slope is. So I picked the point 0.80 and 0, -4. And the slope is the change in y over the change in x, or delta y over delta x. So I have 0 + 4 over 8 - 0. So the slope is a half of this function. Now, you're like, okay, fine. I know the slope is a half. What we're also going to do is do this little trick I learned, and we're going to actually draw what I call an f prime bar. So you're going to do this here, and we're going to look at our function, and I see that my function's increasing all the way. So if my function is increasing all the way, I'm going to put little plus signs here. If it's increasing all the way, that means when I graph the derivative, all my slopes are positive. That means when I graph the derivative, they're all going to be above the x-axis. If they're above the x-axis and I know the slope is a half, then I know it's a constant. It's going to be a straight line with a slope of 0. And this is going to be the graph of the derivative. The line y equals a half. Or you can say f prime of x is a half. Now we're going to do several of these, so look at that and say, okay, as we do more of these, you'll see how this works. Okay? The next one we're going to do is going to have another turn in it. So we're going to do this parabola. Now I don't want you to forget everything we learned earlier about polynomial functions. So this is a polynomial function. So if this is a polynomial function, I can tell what degree it is. If I have one turn, that means it's a second degree. Now when you do the derivative, as you'll see, one of the patterns you'll see is when I do f prime degree, the degree of the derivative, it's always 1 degree less than f of x. So I know in this case, if this is a second degree, my derivative is only going to be a first degree. If it has a first degree, then it's going to be a straight line, because that means there's not going to be any turns to it. Okay, so there's a straight line here. All right. I want to make sure that you cross the x-axis at the right spot. Okay, so let's do that. Right location. So let's do our f prime bar. So I'm going to set it here. Now we're going to use what I talked about before. So here's my f prime bar. I'm going to find out where all my turns are, and I say, okay, here's a turn. That slope right there is 0, so I know it's going to cross right here on the graph as an x-intercept. And then I want you to follow all the way down here, and I want you to draw a line. Okay? Now, I want you to look at the graph from here. From here to where I drew that, my function is increasing, so I'm going to put a bunch of pluses here, and I'm going to say my function is increasing. From where I drew that down here, my function is decreasing, so I'm putting some negative signs, and I'm going to say it's decreasing. Now, what does an increasing function mean? Well, if I'm going to sketch the derivative, that means I'm going to go above the axis, the x-axis, and below, that's decreasing here, below the x-axis when I graph. So, and I know it has to cross here, and I know it's a straight line that has one turn. So really the only way I can sketch this is to go like this. It has no turns to it. I'm above, below, and I go right through there. So I've just sketched the graph of the derivative. Okay? Let's try another one on the bottom here. I have a graph here that has 2 turns in it. So I've got 2 turns. This means it's a third degree. So for f of x, 2 turns means this is a third degree polynomial. That means I know that my f prime of x is going to have 1 turn, because it's 1 less, and that means it's going to be a second degree polynomial, which means that it's going to be a parabola. That always helps when you're doing the sketching. Now let's do the f prime bar here. Okay, f prime. Now, look for your turns in your graph. Say, okay, the slope is 0 here, so it's going to cross right here, come straight down, draw your line. The slope is 0 here, it's going to cross right here, come straight down, draw your line. My graph is decreasing from here to where I did that, so it's decreasing here. It's increasing between these two. It's decreasing from here to here. It's decreasing. What does this mean when we sketch the derivative? It's going to be above the x-axis. Oh, sorry, it's below right here. I apologize. It's going to be below the x-axis here, above right here, and below right here. And remember, you've got to go through these 2 points here. So if it's below, I've got to come on, and you're going to come up here a little bit because I got to turn and come back down to go back below, and it's above in between. Now I've just sketched my derivative of f prime of x. Okay? All right, let's look at this last one here. And this one's very similar, so if you want to stop the video and see if you can do this yourself and then turn it back on. I'm not going to stop, I'm going to keep going. So here's my original function. Again, this one has 2 terms, which means it's a 3rd degree polynomial. If I do my f prime of x, that means I'm only going to have 1 term, or be a 2nd degree polynomial. So that means it's going to be another parabola. So this one's a little bit better than the one we had before. Now let's look at it. I have a 0 slope here. That means it's going to be an x-intercept on my graph, and I draw the line. 0 slope here. That means it's going to be an x-intercept on my derivative. Come down here, draw a line. I'm increasing my function, decreasing my function, increasing. So increasing, decreasing, increasing. So this is my f prime bar. So if I want to draw the derivative, it's going to be above, below the x-axis, and above. So this one will look a little bit like this. As long as you go through your points, and I didn't do a really good one, so let's undo that one. Let's draw this again. Gotta make sure I go through those points. Okay, so there's a sketch of my derivative. Now the last thing I'm going to show you on here is how to sketch a derivative with a bunch of clues, and I think I'll probably make another short video on how you actually graph the derivative. So this will be the last part of this one. So if they give you a bunch of clues like this and they want you to sketch the graph, and I probably should have said that this graph is continuous, so there's no holes or breaks in this graph, so let's assume that it is. I probably should have said that. And we're going to sketch this graph, and we're going to look at what clues they gave us. Well, they said f of x is 0, or y is 0 at x equals -5, x equals 0, and x equals 5. So that means the point -5 zeros on my graph, 0 zeros on my graph, and 5 zeros on my graph. So they gave us some points for that clue. Then they said as x approaches infinity, my function is getting larger. So as I go this way, my function is going to be going up. Okay. It says here, as x is approaching infinity of my function, it's approaching -3. So this is a horizontal asymptote. And then they told you, oh, the slope is 0. The slopes are 0 at these points. That means these are going to be turns in my graph. Or if you want to say maxes and mins, maximums and minimums. Okay, so let's do that. Now I'm going to use all these clues, but I'm going to make a big graph down here. So let's make a nice big graph. And I'm going to put in all those points that they said. All right, so here's x and y, or f of x. And they said 5, 2, 3, 4, 5, 6, 7. So here's 1, 2, 3, 4, 5, and a 7. We talked about that. Here's a 0, -1, 2, 3, 4, 5, -5, and they talked about -3, so I'm kind of put them all in here. Now I'm going to change the pen color so we can actually graph this, and let's make it purple. Okay, so now let's put the graphs on there. So they said the point -5 zeros there, -3 zeros on the graph, and then they said 5 zeros on the graph. So I can draw these purple points on there. Then I'm going to look at the clues here. It said as I go to a negative infinity, so I'm looking right here, as I go to negative infinity, I'm going to infinity. So that means my graph is going to go up, and it's got to cross that point there. Okay. Then they said at -3, the slope is 0, so it's going to be a turn. I shouldn't have put this here. I'll have to erase this. Hang on a second. I shouldn't have put -3 on the graph. I apologize. Let's undo that. I could just erase this. There we go. Okay, so I shouldn't have put -3 there. I should have put the point here, because the point -3 zero is not there. It was 0, 0. I misspoke myself. Sorry. But they did set at -3 that the slope is 0, so that means I've got a max or min, so it's going to turn there. There's the slope is 0. Okay, then it's going to come up through here, and then it said at 2.5, so that's about here. I've got another slope is 0. And then it says I've got to go through this point here because this is on my graph. And then it said at 7 the slope is 0, so that's going to be another turn. Now the one thing I'm a little confused is we haven't done anything with this right here where as I go to infinity I'm approaching -3. So I'm going to put -3 here. Here's -3. It's really a horizontal asymptote. So it said it's approaching that. So there's a couple ways to do this. It's got to turn here. So I can either have it turn here and then come down and approach that, or you could have it go down. Well, that's not really a good. Let's do this part right here. I'm going to have it erase a little bit more. I think I'm going to have it come down and have a 0 thing here and then approach -3. There, that's a little bit better. So now I've done everything that I said. I went through all the 3 points that it said. I have a 0 slope here. At 2.5, I have a 0 slope here, and I have a 0 slope down here at 7. I'm approaching -3 when I go to infinity, and when I go to -infinity, I'm approaching a positive infinity. So there, I just used all the clues they gave us to sketch the graph. Well, that concludes this video, and I'm going to do a short one on how to actually graph the derivative and talk about continuity. So